My name is Jason Furtado. I'm an assistant professor here at the School of Meteorology at the University of Oklahoma. Within the School of Meteorology, I teach a few courses, but mainly courses related to climate and climate dynamics. I've taught Intro to Weather and Climate, Radiation and Climate, and also a statistics course for climate dynamicists. I was born and raised originally in New England. I grew up in Providence, Rhode Island, so it's quite a ways away from Oklahoma. Actually, I'd never been to the state of Oklahoma until I received this job. I went to school at a school called Linden State College in Northeast Vermont. Small school, but a really great meteorology program. That's where I got my bachelor's degree in meteorology and math. From there, I went to Colorado State University and achieved a master's degree in atmospheric science. And then I received a PhD in Earth and Atmospheric Science from Georgia Institute of Technology in Atlanta, Georgia. I pretty much knew I wanted to do weather and meteorology since I was about 7. And I just one day woke up and literally just something clicked. I loved going outside, looking at the clouds. I turned on the Weather Channel, watched it 24 hours a day, 7 days a week. My parents got a little annoyed by that, but it was a lot of fun. I did it all the time. And then I just tried to learn as much as I could about meteorology. I went to the library, I watched television programs, I went to local TV stations and met the local TV meteorologists. And once it came time in high school to decide where I wanted to go for college and what I wanted to do, it was a no-brainer. I knew I wanted to do meteorology. And so I started looking for schools, and a school that was nearby in New England was Linden State College, and I had known about it since some local meteorologists had gone there. Plus Jim Cantori on the Weather Channel, that's where he got his degree, so I decided, sure, I'll go there. So I went there. It was a great 4 years, learned a lot of stuff, did a lot of internships, and then one internship that I did in my last year was actually at NASA Goddard down in College Park, Maryland, or Greenbelt, Maryland. And when I was there, that's where I got exposed to doing research on climate. And then again, it was like another click, and that was what I decided that I wanted to go to graduate school to pursue an advanced degree doing climate research. And so I looked for graduate schools, went to Colorado State, did a master's there, and did some research on coupling between the troposphere and the stratosphere, so the next layer of the atmosphere right above the troposphere, and how those two interact in terms of weather and climate. And then I started gaining a lot of interest in doing more stuff on El Nino and Pacific stuff. So I went to Georgia Tech, where there I studied different flavors of El Nino, so different types of El Ninos. There's El Ninos that form in the eastern part of the Pacific Ocean, and then El Ninos that form in the central Pacific. And so my work was basically contrasting those two and how those two different evolve differently and what impacts they have differently on weather conditions, especially in the wintertime across the northern hemisphere. But then long term, so looking at climate change regarding those El Nino patterns. After I got my degree, I kind of wasn't too sure, to be honest, whether I wanted to be into faculty or if I wanted to do just research. So I actually went and I got a job at a private industry company where I was for 4 years, right outside the Boston area. And there I had the opportunity to do research, continue doing research, publishing papers and all of that, but also applying it. So making client forecasts, doing client-driven research projects, building models for clients, building products for clients. So I got to see kind of both sides. And that was really, really interesting for me. And but I still really loved the research side a lot. And so towards about my 4th year, I kind of decided that I wanted to focus more on the research. And then I had a chance to actually teach at a college. When I was a graduate student, I did a lot of teaching assistants, or I was a teaching assistant. So I had been in the classroom, done lectures, etc. But then I had the chance to actually run 2 classes. So at Boston University for a year, I taught 2 classes there. And it was a great experience, and once again, it just kind of renewed that, okay, this is what I really should be doing. I really should be in a faculty position, teaching and doing research. So once that was decided, I started looking for faculty positions, and here I am today, here at the University of Oklahoma. The group here or my research group here focuses on climate dynamics, large-scale climate dynamics. And I like to use it in an applied side. And what I mean by that is not just studying large-scale climate patterns, for example, studying El Nino, studying high latitude interactions between snow and sea ice in the atmosphere, stratosphere-troposphere coupling, the MJO, Madden-Julian oscillation. These are all patterns that I'm interested in and studying and understanding dynamically how they evolve. But then I want to take that one step further, and I want to make sure that it's applied to something. So one of the applications that I do is on using these climate patterns to help to improve long-range forecasts. So we're talking about forecasts 2 weeks to 2 to 3 months, or the subseasonal to seasonal time scale. So how can we integrate these patterns and the knowledge and evolution of these patterns to help to improve forecasts within that time frame? Now, our weather models go out to about 10 days. But beyond that, there's actually a lot of need to get really accurate, or at least a good picture of what weather will be like for a month or the next 2 months. So you can think about agriculture, you can think about energy demand, energy usage, especially in the winter. Is it going to be a cold winter or a cold month? That can all factor into how much energy is going to be needed, or vice versa in the summer. If it's going to be hot, there's an energy demand needed by the energy companies to be ready for that. So agriculture, energy demand, city planners, how much do we need to budget for snow this year because of the possible winter conditions? These are all things that affect everyday lives. And so extending predictability by bringing in knowledge of these climate patterns is one of the main focal areas of my research group. Then on the other side, on the very long range, so we're talking about 10, 20, 30 plus years, how do these climate patterns, how are they going to change under future climate change? And what could that possibly mean for making decadal projections? So what's the conditions going to be, say, in Oklahoma in the next 30 to 50 years? The climate, will it be a rainier climate, drier climate, warmer? All of those things are all things, again, that are going to impact people's lives. It impacts planning. How do we plan water resources? If you're in Oklahoma and the next 30 to 50 years, there's higher chances of, say, drought based on certain climate pattern, people can start to plan for those things and get water resources or other city management, urban planning, etc. So again, how do we understand these climate patterns and then use it effectively to make planning decisions, policy decisions, etc., for, in this case, future climate change? So those are kind of the two main areas that I work with. My group works with observations, so we look at a lot of different observations and try to synthesize those. We use coupled climate model output, and we also run some climate models ourselves to experiment to see what sort of these changes are and whether or not we can understand the changes in the context of these large-scale climate patterns.